ACF, the online platform for agriculture engineering GATE examination. And this is all about me. Now coming to the first question, that is based upon the discharge over the weir. That it is given that 90-degree triangular weir and having a head of 36 centimeter, and the same water discharge is passed through the rectangular weir that has the length of 1 meter, and it is asking about the head over the rectangular weir by using French's formula. Friends, you should first know the basic formula for triangular weir or triangular notch. That is 8 by 15 into CD into root 2Z into 10 theta by 2 into h to the power 5 by 2. This is the formula for, you remember this formula. And this is the formula for discharge over rectangular weir. That is CD into 2 by 3 into root 2Z into L into h to the power 3 by 2. And friends, this is the formula for trapezoidal weir. That is trapezoidal weir or trapezoidal notch, both we can say. And friends, you know that trapezoidal notch is the consist of both rectangular and triangular weir. You see here in the formula, that is, it is the sum of both triangular and rectangular weirs. That is 2 by 3 into CD into L into root 2G h to the power 3 by 2 plus 8 by 15 means both the formulas are joined together, and you can see in the diagrams also that it consists of trapezoidal notch consists of both triangular notch and rectangular notch. So both we can add both the formulas and we can get the discharge of trapezoidal notch. And friends, one thing you can be careful here, that here the theta value we are considering in triangular notch, that is theta by 2. Theta is the whole. Suppose in question it is saying that 90-degree triangular notch, then we consider that is the theta by 2 value, means 90 by 2 is equal to 45 degree. So tan 45 is equal to 1. But friends, these are the basic formulas. But on advanced level, we have got some derived formulas. When we are keeping here the CD value and tan and theta value, then we can get some derived formula. That also you have to remember, because many times in questions it is not given about the CD value or other values are not given. It has simply said that discharge is this. Then you can easily put that formula. See here that 1.38 into h to the power 5 by 2. This is the formula for triangular weir. You remember it. Once again I will repeat. That is 1.38 into h to the power 5 by 2 is equal to the Q, discharge of triangular weir. And here the h value is, all values are in SI units. H value are in meter and Q value is in meter cube per second. And similarly for rectangular weir, that is 1.84 into L into h to the power 3 by 2. That is, all values are in SI unit. You remember it carefully. Don't play with the units. So you simply keep all the units in SI unit. Then after you can calculate, simply put the values and you can get h value as 0.15 meter, that is 15 centimeter. And friends, here is the next question. That is based upon the manometer, and the difference in mercury level of manometer is 20 centimeter. And the specific gravity of oil and mercury are 0.8 and 13.6, and it is given that G value is given, and it is asking about the pressure difference. So friends, first of all I will give you the concept of manometer. You remember this formula, that is P1 minus P2 P1 minus P5 is equal to rho m minus rho w into Z by GC into H. Friends, here don't bother about GC. GC is simply the reference gravity, means we can consider it 1. GC value is 1 and the G value is our acceleration due to gravity, that is 9.81 value. And friends, here this manometer pressure formula is derived by using the continuity equation and energy balance equation. You simply you do energy balance and continuity equation, you can get this formula, and I will suggest all of you to please remember this formula, because this formula many times question have been asked on these formulas, and you can easily, you don't have to do all the calculation and to get the final formula. You simply remember the final formula and you put in the question and you can get the answer. And friends, see here that by using the formula, difference in pressure is equal to Pm minus P oil into Z into H, and simply I have put the values 13.6 into 1000. Friends, you should be very careful about the units. 13.6, here see in the question, 13.6 is the specific gravity of mercury, not the bulk density of mercury. This is the specific gravity is the density of mercury with respect to water, and you all know that water density is already given in the question, that is 1000. So you have to multiply with 1000. So I have multiplied with 1000 with both values, density of oil and density of mercury, and I have got the answer, that is Newton per meter square. And friends, this is the next question. Here it is given that the height of wall is 5 meter and the density of soil is 1.9 into mg per meter cube, and angle of internal friction is 28 degrees centigrade, and it is asking about the active and passive earth pressure per meter of length. Friends, you should see here carefully that it is given that per meter of length, not simply asking that active and passive earth pressure. So many people have done wrong here, but you should little bit take the concept of active and passive earth pressure. Here you see in the above formula that is highlighted with white color mark, that is PA is equal to gamma H into KA. This is the formula of earth pressure for active soil, means active earth pressure formula. You clearly remember that active earth pressure formula is PA is equal to gamma into H into KA. But when it is asking about active earth pressure per unit of length, then you don't use this formula. You use the formula that is PA is equal to, that is given in the downside, that is PA is equal to 1 by 2 into KA into gamma into H square. You see here that H square by 2 is used in the second case, and in the first case that is only simply H by H is used. So this is the second case is the formula for active earth pressure per unit of length. You see the second formula, this one. Now this is in the case of passive earth pressure, it is similar to active earth pressure, only that you see here in the case of active earth pressure, the Ka value is 1 minus sin phi divided by 1 plus sin phi, and in case of passive earth pressure, the Kp value is 1 plus sin phi divided by 1 minus sin phi, means reverse of Ka, means 1 by Ka, and remaining everything is same for Kp and Ka value, whether it is active earth pressure or active earth pressure per unit of length. And you see here also I have written with clear note that in note 1 it is for pressure per unit length, that is 1 by 2 into K into gamma into H square. I have not mentioned whether it is Ka or Kp, both you can use, but I have clearly mentioned that pressure per unit length. And in note 2 it is written that for pressure of soil K into gamma into H. And friends, for active I have calculated that K value 1 minus sin 28 divided by 1 plus sin 28, and you simply PA you can get 1 by 2 into. Friends, you should see here carefully that gamma value is 1.9 into 10 to the power 3 into 9.81. You see here in the question, you should little bit be clear with the units and dimensions. You see that 1.9 mg per meter cube. Friends, mg is the mega gram, means megagram is 10 to the power 6 gram, but we are simply converting it into the SI unit, that is kg. So we can get that 1 mega kg is equal to 1 m kg. 1 means 1 mega kg is equal to 1000 kg. So I have simply multiplied it with 1000 and I have calculated the PA value, that is 84.11, and similarly I have calculated the KP value, that is 1 by Ka is equal to 2.77, and PP value, that is 645.38. Now friends, this is the next question, that is based upon the confined aquifer and unconfined confined aquifer and the percentage change in its discharge. It is asking. It has simply given the thickness of aquifer value, diameter is given, the drawdown is given, radius of influence is given, and the hydraulic conductivity is given. So friends, you see that you all know that the formula of discharge for confined aquifer, that is 2 pi kb delta S divided by ln r by r1. So I have, in case 1, it is given that the B1 value means thickness value is 10 and the R1 value means radius of well value is 0.2 means 20 centimeter, but you convert it into SI unit, then you can get 0.2. And in case 2, it is the thickness value is doubled and the radius of well is reduced to half. So in case 1 and case 2 I got the values. And friends, you remember always that whenever it is asking whether it is percentage increase or percentage decrease, you should always take the first value in the denominator. Means you should always calculate the percentage increase or percentage decrease with respect to the first value whatever you got. So here I have put the Q1 in the denominator and Q2 minus Q1 divided by Q1 into 100, that is 83.72 is the answer. Here the next question, that is based upon the concept of heat exchanger, that an oil at 120 degree centigrade at the rate of 20 kg per minute is entering and is cooled by the water entering at a temperature of 30 degree centigrade at the rate of 50 kg per minute, and the specific heat of oil and water is given and the effectiveness of heat exchanger is given. Friends, for solving questions of heat exchanger, I will give you some concept. You see this, you remember this concept and you can apply to all previous year questions. It can be easily solved and the upcoming year questions are also solved by this formula. So you see here that friends, you should remember that always in the denominator part for effectiveness of heat exchanger, we should write we should write both the equations in denominator and numerator and denominator. And in the denominator we always consider the minimum, means whatever the minimum value will come, whether it is Cc or whether it is Ch. When the Cc value is coming in the denominator, you should simply multiply with Thi minus Tci. Here I represents the inlet temperature, means whatever with what temperature the water or the oil or whatsoever liquid is entering into the exchanger, and O represents the outlet temperature. And you see that when the Cc value is greater than the Ch value, then we put Ch value in the denominator, and when the Cc value are less than the Ch value, then we put the Cc value in the denominator, and this is the simple concept. You see here that in the solution, that is friends, many people are confused that whether Cc value or Ch value is the specific heat value, specific capacities values. No, it is clearly that it is Cc and Ch values are not the specific capacities value. These are the values of the product of specific capacities and the flow rate of that liquid. Means you see here, for Cc value I have multiplied with mc into Cc, means the mass flow rate of the cold fluid into a specific capacity of the cold fluid. And for Ch value, mh into Ch. Don't simply take the specific capacities. These are the product of mass flow rate and specific capacities, and then only we see that which value is larger or which value is lesser. We considered CH or CC value, that is product of mass flow rate and specific capacities of that liquid. And I have put in the formula, that is effectiveness is equal to 0.7 is equal to Cc into, friends, you remember, I will once again suggest you remember this formula and you are able to solve all these type of problems coming in the examination. And this question is looking very lengthy and very dangerous type, but friends, genuinely it is very easy question. You only have to read the question carefully and understand the question, what it is saying in the question and what it is asking. You simply read the question. Saturated stream at 121 degree temperature is used to sterilize pineapple juice by direct stream injection. The initial temperature of juice is 80 degrees centigrade, and after sterilization the temperature of diluted juice is 95 degrees centigrade, and enthalpy values of streams are given and a specific heat of juice is given. So friends, here you should only take, here you can simply see that for the juice the inlet temperature is 80 degrees centigrade and the outlet temperature for the juice, diluted juice. Friends, here see I have marked with red color, that is diluted juice. Diluted juice means juice plus water. You you visualize this concept, that here in the starting it is given that simply juice, but in the outlet it is given that diluted juice, means that the juice is mixed with water. And from where this water come? This water come from the stream, and the outlet temperature of diluted juice is 95 degrees centigrade, means the outlet temperature of juice plus stream is 95 degree temperature. Here you can't clearly given that outlet temperature of a stream, but you see in the question and visualize by yourself, and then you get the clue here that the outlet temperature of both juice and stream is 95 degrees centigrade. So here you can see that the H value is given, means enthalpy is given. So friends, enthalpy is the if you see the definition of enthalpy, that it is the amount of heat, amount of energy present in a body. Enthalpy is, you remember the simple definition of enthalpy, that is amount of energy present in a body. And for calculating the energy, we should multiply the enthalpy with the mass of the body. Means here you see by unit also, the condensed water enthalpy is given, that is HF value is given, that is kg per, means kilojoule per kg. Value of enthalpy, unit of enthalpy is kilojoule per kg. When you multiply this enthalpy value with the mass of the stream, then you can easily get the energy of the stream. So initially the stream is present at 121 degrees centigrade. So initially we should take the enthalpy of a stream at 121 degrees centigrade. That is, I have marked with red color, you see in the second column, that is 2707.1. It is the enthalpy of stream at 121 degrees centigrade. And finally the stream comes at temperature of 95 degrees centigrade. And you also see here that it is diluted juice, means the stream is not present in its vapor form, its form converted to liquid form. So the final stream is present at 95 degree temperature and in the form of liquid. So we should consider H2 value as in the first as 397.9 kilojoule per kg, which is given in the first row and first column. So you see the solution here. Heat utilized by juice is equal to mj. Mj is the mass of juice into C into 95 minus 80. That is the temperature difference, and the specific heat of juice is given. And here friends, you see the note. Note 1. HF is the enthalpy, amount of energy present in the stream at that time. Means initially the stream is at 121 degree centigrade temperature. So its HF value is 2707.1. And finally it comes in liquid phase at a temperature of 95 degrees centigrade. So you can simply use the heat balance equation, that is Ms heat given by stream is equal to Ms into H121 minus H95, and you use the equation 1 is equal to equation 2, and you can simply get the ratio of mass of juice divided by mass of stream. Friends, I will give you one logic of solving this type of questions. Friends, whenever this type of ratio of mass of juice or mass of anything is coming, and in the denominator it is asking that mass of stream, you should always remember that this ratio should be greater than 1. If it is less than 1, then the process is uneconomical. And in GATE examination, generally the questions are only those questions are asked which are economically feasible. So always your answer will be greater than 1. In this case it is coming so much greater than 1, that is 39.47. But if it is a closed question, means the values are coming, suppose you are little bit confused in question, you can easily visualize by your answer that its value should be always greater than 1. The next question, this is the question of pharmacy. And friends, I will suggest you people to read pharmacy very carefully, because you don't have sufficient materials and sufficient books for pharmacy. So you should read each and every question very conceptually, and you should make your own notes by reading these questions, because these questions itself are the concepts. So you can't just simply read the questions or solve the questions like I am solving question. But these questions, each question is a concept in pharmacy. So you should make proper notes of pharmacy. You see this question, that 4 rotating discs are given with width of 60 centimeter, and the specific power loss due to friction is 2.5 kilowatt per meter of cutting width, and a specific energy requirement is 2 kilojoule per meter square, and operated speed is 6 km per hour, and it is asking about PTO power requirement. Friends, you see that PTO power requirement is the sum of total power requirement, whatever the power loss in friction plus whatever the power loss in cutting, or whatever all we consider all other losses, and then we sum up all the losses and all the useful powers, and then we can get the PTO power requirement. So you see here in the solution, firstly we should calculate the total width, that is 4 into width of each disc, that is coming 4 into 0.6 is equal to 2.4. Then the power loss due to friction. Here friends, you can see that the power loss due to friction is per meter 2.5 kilowatt per meter of width, and the total width is 2.4 centimeters. So 2.5 into 2.4 is equal to 6 kilowatt. That is power loss due to friction. Now coming to the power requirement in cutting. So friends, power requirement in cutting is per meter square, means it is cutting in per unit of area. 2 kilojoule of energy is needed. Friends, see here that it is energy kilojoule, it is given that, means it is given that 2 kilojoule of energy is needed per meter square of area, and we have to calculate the how much power is needed in cutting total field. So we should multiply the width of the rotatory disc mower with its velocity, and the velocity is given in 6 kilometer per hour. So friends, I have in previous videos I have told you that you should be very clear with the units and dimension chapter. See here that unit is speed is given in kilometer per hour. So you can easily convert it into meter per second by multiplying 6 into 5 by 18. Whatever you have studied in your intermediate classes, and you can simply multiply the 2 into 2.4 into 6 into 5 by 18 is equal to 8 kilowatt. And for total power requirement, you should add both these power, 6 plus 8 is equal to 14 kilowatts. That is the correct answer. And this is the next question. Question is very easy if you understand it, but if you don't understand it, then it will be so much of lengthy. Friends, read this question very carefully. Here it is given that power coefficient Cp value is 0.4, total pumping head is 20 meter, and the discharge is 15 liters per second, and the wind mean velocity is 8 meter per second, pump efficiency is 70%, density of air and water is 1.2 and 1000 kg per meter cube, and transmission efficiency of wind turbine is 90%. So see here in the solution. First of all, you should calculate the power output of pump. You all know that power formula for pump is rho z h into q, means pressure into discharge. So I have put simply the value. This is the power output. You see in the question that the discharge, total pumping head and discharge of pump is 20 meter and 15 liters per second respectively. So you should simply use unit conversion of liters per second to meter cube per second and get the power output of pump. Now friends, this power output of pump is divided by its efficiency, then you can get the power input to the pump. And the power input to the pump is equal to power given by the turbine. Suppose the turbine will give some power, and that is the input power to the pump. So for calculating the power driven by the turbine is equal to, you all know this formula, that is 1 by 2 into Cp into rho A into V cube into efficiency of turbine. You friends, you see here that efficiency of turbine, not the efficiency of pump. You see here in the question, that is efficiency of turbine is 90% and efficiency of pump is 70%. And also you see one more thing, that is rho A, means rho is the density of air, density of water. You see that for calculating the power driven by the turbine, we should consider the rho A value, means density of air value, not the density of water value. So we can get the power given by the turbine. And now for calculating the efficiency of pump, we all know that output power of pump divided by input power of pump. And that is, friends, for calculating the area, we should simply keep it as pi by 4 into d square. We don't have, it is in the question, it is asking the required diameter of wind turbine. So we don't have the turbine diameter, it is asking. So we should assume it as d value. And now we should keep in the formula for efficiency of pump, that is output power of pump divided by input power of pump, and we should keep all the values and we can get the value of D, that is 6.95 meter. Based upon the traction chapter, friends, you should read the traction chapter very carefully and you should understand each and every concept by making its free body diagram. Sorry, I have not made the free body diagram of tractor in this problem, means in this solution, but in further problems I will make the free body of diagram of tractor, because only by that way you can understand the concept of traction properly. There is no other way to understand traction. So you see here in the question, that is total weight of tractor is 25 kilonewton and wheelbase is 2.2 meter and center of gravity lies at 0.7 from the center of rear axle, and drawbar hitch is 0.5 meter, and friends, here see here, weight on the front wheel becomes 20% of static weight, and it is asking about net coefficient of traction. Now firstly, you all know that there are two types of tractors. One is two-wheel drive tractor and second one is four-wheel drive tractor. You should don't confuse that. Many people are asking that many where it is using for coefficient of traction, it is using the formula that pull divided by rear wheel reaction, means RR. Many times it is using that formula and many times it is using that formula, that is coefficient of traction is equal to pull divided by total weight, means RR plus RF. So you should don't be confused in such cases. You should simply read what type of tractor it is, whether it is two-wheel drive tractor or four-wheel drive tractor. You see here in the question, it is clearly mentioned that it is a two-wheel drive tractor. So you should use the first formula, that is mu is equal to pull by rear wheel reaction. And if in the question it is given a four-wheel drive tractor, then you should use the second formula, that is mu is equal to pull divided by total weight, means RR plus RF. And friends, see here, it is given in the question that the front wheel axle weight is 20% of static weight. So you should first take the front wheel reaction, that is 20% of 25 is equal to 5 kilonewton. So when the front wheel the weight is 5 kilonewton, then automatically you know that total weight of tractor is 25 kilonewton, and the 5 kilonewton is on the front wheel, then the remaining weight is on the rear wheel, means 25 minus 5 is equal to 20 kilonewton on the rear wheel, and it is also calculated here. Now friends, for calculating the amount of pull, you should simply use the concept of moment about the rear wheel axle point of contact with the ground. You should take the moment of all the forces acting on the tractor about the point of contact of rear wheel axle with the ground, that is at the point of contact of RR. So we know that RR term should be 0. When we considering moment about RR, then RR value automatically being going to be 0. So you calculate it by pull into 0.5. Here see friends, it is given that the drawbar hitch point is 0.5 meter above the concrete surface. So pull into 0.5 plus 5 into 5 is the RR value. 5 is the RF value, means front wheel reaction value. 5 into 2.2. Here see that 2.2 is the wheelbase, is equal to 25 into 0.7. Friends, many people are confused in such type of questions that which value should I take positive or which value should I take negative. You can decide it by using the Fleming's left hand rule. You should simply see the direction of torque, where the direction of torque is inside the plane or outside the plane. For inside you should consider one sign, and for all outside direction of torques you should consider another sign. And after this you got the pull, that is 13 kilonewton, and then you calculate the coefficient of traction, that is, since it is a two-wheel drive tractor, so coefficient of traction is 13 by 25 is equal to 0.65. The very easy question that is based upon the trapezoidal rule. You simply have to remember the trapezoidal rule formula, and areas values are given, A1, A2 values are given, and contour interval is given, that is 1. The contour interval you can simply see that is 100, 100, 102, 103. So contour interval is 1. So you can easily multiply the area with the height, and you can get the estimated capacity, means volume of the pond. So this is the, you all know the contour formula, trapezoidal formula, that is h by 2 into q naught plus qn into plus 2 into q1 plus q2 plus dot qn minus 1. And simply q naught value and qn values are 440, 1240, and q1, q2 all values are given in the question, and you can simply multiply and getting the answer, that is 4860 meter cube. I am sorry, I have not written the units, but it is 4860 meter cube. And this is the next question, that is also very easy, not so much thing in this question. You simply a specific speed is given, that is 1800 rpm, and discharge is given, and total head is given 25 meter, and it is asking about a specific speed of pump. But friends, see here is the formula. Friends, you remember one thing, that all values should be given, in the form of SI unit. The head value is in meter, the Q value is in meter cube per second, not in liter per second. Many people are confused and they are making mistakes, that they are thinking that if Q value is means discharge value is given in liter per second, then we should simply put the liter per second, but it should be in meter cube per second. And the N value is given, and NS values are given in RPM, so don't do anything with N and NS values. And friends, one more thing, you see here, the head is given, that H value is the head per stage. Suppose in this question it is not given anything, it is simply given that total head is 25 meter. And suppose it is given in the question that total head is 25 meter and it is a pump of 5 heads, 5 head per stage. If it is given that there are 5 heads are present in this pump, then you should simply divide the 25 by 5, means is equal to 5. It is the H is the head per stage. Don't confuse that it is simply the head per stage. Here the question is easy, nothing given about the stage, so you can easily use here 25. But if in questions, in critical questions and complex questions, the head per stages are many times. So here is the solution. That is very simple. You see here that Q value is 15 is divided by 1000, that is 0.5, and the head is 25, and you can simply get 36 RPM. So